Okay, this is part 2 of the simulation, and we're just going to demonstrate keychain transmitter button 1, start button 1 input. This time there's going to be no brake pedal, and the general flow of the program is going to be from keychain through start button 1, wakes the chip, and it's going to see that the start button was pressed. And if the engine is running, when someone presses the start button, it's going to see that the engine is running, and it's just going to shut off the engine, power down, and go back to sleep. Kind of a fail-safe that the car never tries to start. The starter never tries to start it while it's running. But if it detects that it's not running, it's going to go, the flow of the program is going to be straight through here. It's going to check to see whether the engine's running. It's going to see that it's not. It's going to turn the starter on for up to 4 seconds and continually trying to detect whether the engine is running or not. It's going to try to start the car a maximum of 3 times with a 5-second delay in between each attempt. And so there's each time. It's going to check every 1/5 of a second. It's going to check for tach input and count the pulses over 1/5 of a second. And if it senses that it's on, it'll try and compare the number of actual tach in pulses with that was recorded before during the tach learn part of the program and stored in EEPROM. So it'll do that compare. If the car is running, then it'll shut off the starter relay, and it'll go to mode 4 in the program, which is a state that whereby it idles for 10 minutes or until the driver presses the brake pedal, in which case the driver has 10 seconds to insert the key into the ignition and turn it on, after which it goes to sleep and waits for another external interrupt. Keychain transmitter button 1. So here we are in the program, and it's reset. So I'll just do initialize ports again. I'll stop it, run it, and it's back to sleep, waiting for a button 1 input again. And so I've set, what I'll do here before I start is I'll disengage the stimulus file, so there are no strobing pulses on real-time clock counter pin 4 on port A. So we'll just go detach, click OK, and I'll just show you where the breakpoints are. There's one here at mode 2, just before it enters that loop where it checks continually for tach input to know whether the car is started or not. So I'll set it off running, and we'll simulate a button input. And here it is here. We're just going to toggle input. We see that the brake pedal is off. We toggle input, and there it is. It brakes at mode just before the call to mode 2. And so we'll step through that. Step into mode 2. Set a breakpoint, run it again. Take the breakpoint off. Step back into the loop, try again. So at this point it's going to turn on the starter, and what I'll try to do here is I'll turn on the strobing pulses again that simulate the tach input pulses. Attach our stimulus file, click OK, and actually no, what I'll try to do is I'll detach it. What I'll try to do is I'll try to click it on the fly and try to catch it inside this loop. And so it's got a total of, within 4 seconds, we've got 4 seconds to act. So I'll put the focus here on the main program window, and we're on clock stimulus tab. So I'm going to set it off running with F9. It's the F9 key to hit run, and I'll be set here clicking away on the apply button. The stopwatch, 0 the stopwatch. Here we go, F9. And so we see that it stopped here. It's just ready to call mode 4 and go into an idle for 10 minutes. But milliseconds, we caught it at 28 milliseconds into the loop. And so that's just a little more than, it must have been the second call to check TAC, not the first one. And that's about as fast as I can move with my mouse click and my mouse on the apply button for the stimulus, TAC stimulus. So here we are, we're going into mode 4, and what I'll do is I'll time mode 4. This is the part of the program where it idles for 10 minutes. I won't simulate a break input just so that we can tell if our 10-minute delay is working or not. So I'll bring back up the stopwatch. We'll 0 the stopwatch and we'll just check, see that our breakpoints are okay down in mode 4. Mode 4, we'll get it to stop exactly when it's finished, right just before it goes to power down. And stopwatch is zeroed out. We'll set it off running, and I'll pause and I'll come back in 10 minutes and we'll check the stopwatch. We go running. We'll see you in 10 minutes. Okay, and we're back, and it's been over 10 minutes. The stopwatch timed out at 622 million microseconds, or 622 seconds, and that is 622.8765 divided by 60 seconds a minute, and that's a little over 10 minutes. This is a discrete event simulator and not real time, so it's not entirely accurate. And that's it for this demo. Thank you.